Hi everyone, we are Group 1 and here is the part 2 of our task in Math and Physics. Here we have the three-dimensional solid shape which is sphere.
So, what is a sphere? So the definition of sphere is a three-dimensional solid object and drawn in shape that has a surface area and volume. So just like a circle, each point of the sphere, it has an equal distance from the center. So this distance is called the radius of the sphere. Some examples of spheres are ball, the globe, and even the planet.
The properties of a sphere. The important properties of the sphere are given below. These properties are also called attributes of the sphere. A sphere is perfectly symmetrical. A sphere is not a polyhedron. All the points on the surface are equidistant from the center. All sphere does not have a surface of center. A sphere has constant mean curvature. A sphere has a constant width and circumference. The image here is the illustration of a sphere.
Here we have the formulas for sphere. The first one we have is the diameter of sphere. The diameter is basically twice the radius and it's from one end to the other end and it passes through the center of the circle or sphere. And the formula for diameter is D equals 2R, where R is the radius. Next is the surface area of a sphere. The surface area of a sphere is the total area covered by the surface of a sphere in a three-dimensional space. The formula for surface area is SA equals 4 pi r square units, where r is the radius of the sphere. Then lastly, we have the volume of a sphere. The volume is the amount of space occupied by three-dimensional object like our sphere. The formula for the volume of a sphere is given as V is equal to 4/3 pi r cubic units. Example problems. Let's start with this problem number 1. What is the volume of a sphere that has a radius of 5 centimeters? Let's start with the equation. V is equal to 4 over 3 pi r cube. So that's the volume of a sphere, and all we need to do in this problem is plug in the value of r. So r is 5, then 5 to the third power, that's 5 times 5 times 5, and that will going to be 125. And 125 times 4 is 500, so the answer is 500 pi divided by 3, and the unit is cubic centimeters. If we want to get the decimal equivalent of that answer, we can just type it in our calculators. Then we will have the value of 523.6 cubic centimeters. Problem number 2. What is the surface area of a sphere with a radius of 8 inches? Well, let's begin by writing the formula first. The surface area is 4 pi times r squared. And we already have the value of r, it's 8 inches. So it's 4 pi times 8 squared. And 8 squared or 8 times 8, that's going to be 64. And if you multiply 64 by 4, that's going to give you 256. So the answer is 256 pi. Now, what are the units of surface area in the case of volume? For volume, it could be inches cube, feet cubic yards, cubic something raised to the third power. Now, whenever you're dealing with area, you're dealing with square units. In this case, it's going to be inches squared or squared inches. So it's 256 pi of squared inches. Any type of area, it could be lateral area, surface area, or just area in general. It's usually unit squared or squared units.
Question. What is the diameter of a sphere with a surface area of 36 pi square feet? Well, using this formula, we could find the radius, the surface, and the area is 4 pi r squared. And once we have the radius, we could find the diameter. So the diameter is simplified to r. So let's say if you have a circle with radius r, the diameter is basically twice the radius. It's It's from one end to the other end, and it passes through the center of the circle or sphere. Now, let's go ahead and find the radius first. So the surface area is 36 pi. So let's cancel pi and then let's divide both sides by 4. 36 divided by 4 is 9. So 9 is equal to r squared. Now, let's take the square root of both sides. So the radius is 3 feet long and the diameter is twice the length of the radius. So it's going to be 2 times 3. So therefore, the diameter is 6 feet long, and so that's how you could find the diameter of the sphere.
And that's the end of this presentation. Thank you for watching.